Hi, welcome to the video on solving systems with nonlinear equations. Solve the system of equations below. List solutions as ordered pairs. We have two equations here. We have a circle, which is the quantity of x minus 4 squared plus the quantity of y minus 7 squared equals 89. We also have a linear equation. Looks like it's kind of written in standard form here. We have x minus y equals 10. So let's not waste any time. Let's get into solving this system. Now, because we have x and y in both of the equations here, and it's not isolated in either of them, we have to decide which equation we want to use. If we look at the linear one, that looks much simpler to isolate one of the variables, and we can then use substitution to replace a variable in another equation. So for instance, let's start out with x minus y equals 10, and let's just go ahead and solve it for x. So if we were solving it for x, we know that we would add a y to each side of our equation here, and it should end up being x is equal to y plus 10. Now we're going to use this to help us solve for y in the first equation. So if x equals y plus 10, we're going to replace this x with a y plus 10. Should look something like this. We have y plus 10 minus 4, and then we're going to square it, plus our quantity of y minus 7 squared equals 89. Now we could go ahead and combine our like terms in here. The 10 minus 4 is going to give us 6. So we're going to say y plus 6 squared. Okay, and then the rest of this here is just the same. I'm just going to jot it down so it just, I don't know, looks visually more appealing to me anyway. So now we've got no x's left, and let's go ahead and let's just FOIL out or multiply this binomial times itself. Same thing with this one, so we can combine the like terms. So y plus 6 squared, remember, is like y plus 6 times y plus 6, which should give us y squared plus 12y plus 36. Our other binomial, when we multiply it times itself, should give us y squared minus 14y plus 49, and this all equals 89 still. So the best way now, we know this is looking like it's quadratic. Let's combine our like terms here and then work on getting it set equal to 0. So y squared plus y squared should give us 2y squared. We have a 12y and a negative 14y, which gives us minus 2y. And then 36 plus 49 is going to give us 85. And we said already that that already equals 89. Now remember, it's quadratic, and we have a y squared term and a y term, which means we can't just isolate the variable because it's got two different degrees. That means we're going to have to set it equal to 0 and use factoring and the zero product property to get our answer. So let's do that. We've got minus 89 on each side. Now we're looking at 2y squared minus 2y. And then 85 minus 89 is going to give us a negative 4. Our whole equation now equals 0. From this point, you can solve the quadratic any way you please. There's multiple ways to do it. If you're a quadratic formula person, you could do that. For me, I would prefer to use factoring. The first thing I can do in factoring here is look for a greatest common factor. 2 is a factor in each of these, so I can say I'm going to factor out a 2, and I'm left with y squared minus y minus 2 equals 0. If I distributed this 2 back through, you'd see I'd end up with the same thing I had. Now this y squared minus y minus 2 is just a trinomial, and we can look to factor that into two binomials. So I'm going to bring my 2 down. It doesn't really hurt anything out there, but we're going to have a y in the front of each set of binomials. We know our signs are going to be different. One's got to be plus, one's got to be minus, because we have a negative 2 back here. And our factors of negative 2 would be negative 2 and positive 1. So if you need to use the generic rectangle and the diamond to factor that, that's fine. I'm just doing it this way for time's sake. It's a little bit easier for me to do it this way. So now if we have 2 times the quantity of y plus 1 times the quantity of y minus 2 equals 0, one of these two factors would have to be 0. So we're going to set y plus 1 equal to 0, and we're going to set y minus 2 equal to 0. And we solve those, we'll get y equals negative 1 and y equals 2. So looks like our intersection between our circle and our line is going to happen at 2 points. We can use these values of y now to figure out our corresponding values of x. Let's take them and plug them into our other equations here. So we're going to say when y is negative 1, we're going to find the x here by plugging in this value. So we're going to say x minus negative 1 equals 10. And that's the same thing as x plus 1 equals 10. And if we subtract our 1 there, we should get x equals 9. So when y is negative 1, our x is 9. That's one of our solutions. And we'll double check it here after we find our other solution. For the second one, we know that y is equal to 2. So we need to figure out what x needs to be. So let's say x minus 2 equals 10. And we add 2 to each side, and we should get x equals 12. Let's take that 12, let's just record it with our 2 here. And now we just need to make sure we double check our solutions with the equations. If we take 9 and we plug it in for x, and negative 1 and plug it in for y into each of these, it should make them true. And the same thing with 12 and 2. And I'll go ahead and do a check here just because I want to make sure that you understand what you're doing. So 9, I'm going to put in there minus 4 squared. And then we have plus our negative 1 minus 7 squared equals 89. And let's just simplify these. This would be 9 minus 4 is 5, and 5 squared would be 25, plus negative 1 minus 7 would be negative 8, and negative 8 squared would be 64. So 25 plus 64 does equal 89. So we know that one is good so far. Plug it in here. If you do 9 minus negative 1, that should give us 10. So we know that one works. I won't write that one down just for time's sake here. And let's plug in our 12 and 2. Let's plug it into this one here. So we've got 12 minus 4 squared plus 2 minus 7 squared equals 89. 12 minus 4 is 8. 8 squared is 64. And then 2 minus 7 is negative 5, and negative 5 squared is 25. So you're going to see here that that is also going to equal 89, so we know that we were on the right track. We plug them in up here. 12 minus 2 is 10. That one also works there. So there you have it. This is solving the nonlinear systems of equations. Okay, remember the easiest way to approach it right now, without graphing it, would be to isolate one of the variables and use substitution to simplify or to combine them and then to simplify it down. If it's quadratic, then you have to take it and make sure that you factor it and use the zero product property. Plug in your two answers there, and it helped us get our other coordinates of the answer. So once again, the solutions are 9, -1, and 12, 2. If you have additional questions, make sure you ask your teacher. Otherwise, thanks for watching, and I hope this helped.